Hey everybody, it's Jenny from Normanus Wright and NSW PEP. Last week I discussed rear door heat exchangers, so this week I want to talk about the most common type of liquid cooling, direct-to-chip liquid cooling. So let's get started. So what is direct-to-chip cooling? Direct-to-chip cooling uses liquid coolant to absorb heat directly from computer chips. It uses a cold plate sitting right on top of the chip, pulling heat away and keeping temperatures optimal. Direct-to-chip cooling is a game changer for data centers managing high-performance computing hardware. It improves energy efficiency, reduces overheating risk, and boosts overall system performance. Let's move this over to draw the system. Similar to the rear door heat exchangers that I talked about in the last video, you'll have a cold water loop. So let's just pull the drawing from that last video. So somewhere on site, you'll have a chiller and a chilled water loop that sends water to coolant distribution units, CDUs, that use liquid-to-liquid heat transfer to cool the liquid loop going to the cold plates on the chips. So let's erase the rear door heat exchanger part of this drawing. So we'll draw in the server rack. Inside the server rack, there are going to be several servers with CPUs or GPU chips which generate heat. So the coolant would go to each server. To make the drawing a little easier, I'm just going to show cooling going into one side and the rejected heat coming out the other side, but it'll all probably just be going into the back of the rack. Let's make a little bit more room, and I'm going to draw a computer chip. Cold plates are mounted on top of the CPU and GPU chips. A non-conductive coolant or water glycol mixture flows through the cold plates, absorbing heat. Non-conductive coolants are used to reduce electrical risk. Between the plate and the chip is a thermal interface material that conducts heat from the chip to the plate. The warm liquid that leaves the chip travels back to the CDU, where the heat exchanger transfers the heat and it goes back into the chilled water loop or cooling tower so it can be rejected outside the data center. Let's move this over again. There are two methods of heat transfer in direct-to-chip cooling, single-phase and two-phase. In single-phase cooling, heat is absorbed by the coolant as it flows through the cold plate. The fluid remains in a liquid state throughout the process. In two-phase cooling, the coolant boils when it comes in contact with the heat source, absorbing heat and turning into vapor. This vapor carries the heat away where it's condensed back into a liquid somewhere else in the system. Let's move this over one more time. So what are the benefits of direct-to-chip cooling? Well, increased reliability and performance is one of the benefits. Direct-to-chip cooling minimizes the risk of overheating and maintains uniform lower operating temperatures, which is crucial for maintaining the reliability and longevity of HPC hardware. It can also be integrated into existing server designs, minimizing disruptions to operations. Also, liquid cooling allows more processors to be housed in a smaller footprint and eliminates the needs for expansion. It's also been shown to have a reduced total cost of ownership. ASHRAE found that data centers using both liquid and air cooling have lower total cost of ownership than air-cooled only systems. So let's bring all this back on screen. So that's how direct-to-chip cooling works. Direct-to-chip cooling is helping data centers achieve higher efficiency and reliability. Don't forget to like and subscribe to our YouTube channel, and thanks for watching. See you next time.